All right, let's go ahead and get started. And I've got Emily up here to talk to you guys about another resource that UNC Charlotte has about supplemental instruction. So,
Hey, I'm the Supplemental Instruction Graduate Assistant, so I'm just going to tell you a little bit about what supplemental instruction is and give you the times for this course. So supplemental instruction is like a group study session you can attend to help you get more acquainted with the material of this class. So that's if you're doing poorly or if you're doing good and you just want to do better. It's all free and it's not remedial. We have 4 sessions offered per week for this class, and you can attend as much as you want. Students who attend 5 or more times in a semester tend to see a grade jump of a whole letter grade, so we encourage you to start going early and go often. So the times for this class are Tuesdays at 5 p.m. in Fretwell 402, Wednesdays at 6 p.m. in Fretwell 402, Thursdays at 12:30 p.m. in Denny 202, and Fridays at 2 p.m. in Fretwell 402. And those are all on our website, as well as all the times for other classes we offer supplemental instruction for.
can I borrow that?
You sure can. It's a little sloppy.
There we go.
Yes.
You're welcome. Supplemental instruction, honestly, is a time that it's for everybody who's taking college algebra can go to any one of these classrooms, because like I said, we offer it 4 times, and we have a student who's very well versed in algebra is going to be sitting there, and they will basically answer any kind of questions you guys have, give you kind of a little mini lecture on the topic matter if you need it, or whatever the case may be. The times usually last for about an hour and 15 minutes, I guess, with the classrooms and stuff like that. And it's a wonderful way of actually getting better at your material and stuff. The more you guys practice, the better you guys are. And again, it's another one of those wonderful resources. If you can't be at my office asking me questions, and of course, we have our little Friday component to the class, which will be Fridays at 12:30. If you can't make that, here's another venue that you can attend to get those questions answered and to make sure your algebra skills are top notch and to help you out with this particular material.
That's all I have. Thank you.
All right. Now, but last time, first off, let's talk a couple of things, because I know a lot of people are beginning to work on their projects and things like that. So I want to basically look up the Hawksware stuff. So let me look on the Hawksware, because this is the thing I want you guys to pay attention to. Due dates. Things are become due here, so I want you guys to really pay attention to that. If you haven't done something or other, you probably got a nice little email from me reminding you to get it done or whatever. Thank God for technology. So I've got quiz 3 due today. I haven't taken that yet. And also, if I want to sit there and do within 1 week and stuff, I can sit there and click on these particular guys, and you can figure out, like I said, the due dates and due times. And like I said, you got your certified. And the goal is to get certified here. You're getting your grades that you can, like I said, that's basically your homework set. Now, let's see here if I can do the dashboard thing here. And what do I want to see here? I want to actually see all my view course. I'll get there. I'm still learning the system myself. It's a little slow, but basically, you kind of want to pay attention. Now, I've got everything dumped in here, so be careful on this. But pay attention to these due dates. That's section 1.3a. That's the first thing that we started our class out with. It is due today. Keep on going down here, and you'll see some more. And I've got section, 1.3a, 1.3b, wherever it happens to be located at. On the bottom, there it is. That one's due on September the 4th. I've got 4.1a due on September 4th. I got 4.1b due on September the 14th. So I'm trying to do these things kind of towards the end of the week type of thing here. But like I said, the goal here is to get these things certified. That gives you the homework grade, put it in the grade book. I am still working on the grade book for the thing. So, it's giving you guys grades, but I'm going to be adjusting that because we got, test grades to go through, homework grades, so forth and so on. So I'm still working on getting the mathematics behind the grade book. So when I get all that squared away, I'll let you guys know about it. But because this was one of the first things we did, I'm making it due today. Also, you've got, like I said, don't forget you've got your quizzes and things like that you need to get done. And so, like I said, we've got quiz number 3 here, which is on our section 1.4. Quiz number 4 here, that'll be due on September the 9th. So forth and so on. Don't fall behind on these particular dates. I've tried to give you guys some extra dates because I know there's still a lot of folks trying to adjust, still getting their software, things working and stuff like that. But, and again, I'm going to be going back behind it and actually working on the grade book. And so the main thing is get that mastery level and being able to move on to the next section, which puts 100 in the grade book and stuff. All right. So the next thing that I want to do is these particular problems down here, and then I have a particular question that I want to focus on. And this is on the last part of section 1.4 before we move on into section 1.5 and polynomials and the like. So, and that was rationalizing denominators. As I mentioned to you guys before, when it comes to having fractions, when there is a radical in the denominator, officially it, quote, doesn't look good. So we like to do something called rationalize the denominator. Get rid of the fraction or the radical in the denominator. Now, most of these problems will have square roots, but it doesn't matter. A few of your other problems will also have cube roots and fourth roots and so forth and so on. It's a game. Now, remember this. When it comes to square roots, to be able to get something out of a square root, you got to have pairs. The square root of a squared is a. The square and the square root cancel. It's the square root of a times a. I have a pair of a's, I get to pull one a out. If I'm doing cube roots, the cube root of x cubed is equal to x. Cube roots and cubes cancel each other out. Because I have I got the cube root of x cubed. I got the cube root of x times x times x. I got 3 x's inside of a cube root. I get to pull one out. So forth and so on. So you have to understand what kind of radical you're playing with. Well, in these particular examples, I'm playing with a square root. So this original problem that I did last time, I'll rework him again. I had 14 divided by the square root of 5. The problem with this guy is there's a square root of 5 in the denominator. I want to get rid of that. Well, 5 is prime. It doesn't factor anymore. That's okay. The fact is I have 1 5. What it really needs is I need to have another 5 underneath the radical to have my pair. So I give him exactly what he needs. So I multiplied the denominator by another square root of 5. And what I do to the denominator, I get to do to the numerator. So it's a ratio of 1. So this ends up becoming equal to 14 square root of 5 over, and remember with square roots or like radicals, when you multiply or divide, you can make it one big radical. This would be one big radical of 5 times 5. Well, there's 2 ways of looking at this. Number one, these are nice numbers. 5 times 5 is 25. What's the square root of 25? 5. And the 5 pops out. The other way I want you guys to look at it is this. I got a pair of 5s underneath the radical. When I got a pair of 5s under a square root, for every pair, I get to pull one out. So this combines up, and I get to pull out a 5 outside, and I'm left with 14 square root of 5 still in the numerator. And this ends up becoming my solution. But what's nice about this solution is it's the same answer. I have just rewritten it such that there's no radical in the denominator. Proof by calculator. I mean, it's the same answer. Let me show you. The original problem was 14 divided by the square root of 5. Some crappy decimal number. There it is. What is 14 times the square root of 5? That thing divided by 5. Exact same decimal number. So it's equal to each other, but in proper mathematics, this guy looks better than this guy because this guy doesn't have a radical in the denominator. Okay? It's simplifying the problem. So let's do this problem. 5 divided by the square root of 3. I want you, directions would say, rationalize the denominator. Well, in other words, I want to get rid of that square root of 3 in the denominator. So I'm going to multiply by, well, I've only got 1 3, but it's a square root. I would like to have a pair so I can pull something out. So I'm going to multiply by another square root of 3, but whatever I do to the denominator, I have to do to the numerator. So I'm multiplying by a ratio of square root of 3 over square root of 3, which is a ratio of 1. So this ends up becoming, in the numerator, just put your two numbers together, 5 square roots of 3, but in the denominator, it's one big radical of 3 times 3. You can either run the numbers or catch the pattern. Since I have a pair of 3's inside of a radical, I get to group them together. Inside of a square root, I get to group them together and pull out a 3. And the numerator, 5 square roots of 3, stays the same, and there's my solution. If you wanted to, you could have run the numbers. 3 times 3 is 9, and the square root of 9 is 3. That's why the 3 got pulled out. Does that make sense? However, on these two particular problems down here, we have something called, it's a rational number, but it's not just a plain old square root. This one I happen to have 4 divided by, look at your denominator, the square root of 5 plus 3. Okay? 4 divided by the square root of 5 plus 3. Now again, the problem here is I want to get rid of my radical in my denominator. The trick to this guy is something special. It is called using the conjugate. It's a special case. Now here's the deal. The conjugate of something like the square root of a plus b is going to be the square root of a minus b. It's the same thing except you change the sign in the middle. So on this particular problem, I want to rationalize the denominator. I got 4 divided by the square root of 5 plus 3. I'm going to multiply by its conjugate. And remember, whatever I do to the denominator, I also have to do to the numerator. So this will be the square root of 5. What's the conjugate of the square root of 5 plus 3? Square root of 5 minus 3. And whatever I do to the bottom, I also have to do to the top. Square root of 5 minus 3. Now I'm going to clean this guy up. Now with non-conjugate pair stuff, when you multiply, just slap the two things together. Look at my numerator. My numerator, I'm just going to get 4 times parentheses, square root of 5 minus 3. But in the denominator, I've got to rewrite this guy with no radical in the denominator. What's going to happen here is I'm really just going to multiply the two conjugate pairs out. Because when you multiply conjugate pairs times themselves, they clean up very nicely. But now, my question to you is this. How do you multiply the square root of 5 plus 3 times the square root of 5 minus 3? What technique would you guys use? Very good. It's called the FOIL method. First, outer, inner, last. Because you got pluses and minuses here. So help me out here. What is the square root of 5 times the square root of 5? Square root of 25, which is 5. Because they paired up. Outer, square root of 5 times a negative 3. Well, they're not like terms, so just put them together. That'll be minus 3 square roots of 5, because it looks better to write that. What is positive 3 times the square root of 5? That would be plus 3 square roots of 5. And then you got last. What is positive 3 times a negative 3? Negative 9. And this is what happens when you multiply conjugate pairs times themselves. Or when you fold it out, the outer inner stuff always cancels. What cancels in this thing? The negative square root of 3 plus the square root of 3. And you're left with the solution 4 times the square root of 5 minus 3 divided by, what is 5 minus 9? Negative 4. Does that make sense? You can clean them up some more if you want to, but this is the answer. And I've rationalized it because there is no radical in the denominator. It, quote, looks better. But personally, I cleaned it up a lot more. I'm going to clean it up some more because I've got strict multiplication division when I left things factored. What is 4 divided by negative 4? Negative 1. So this part ends up canceling with a negative 1 times the square root of 5 minus 3. And if I really wanted to make it look good, I'm just going to distribute the negative 1. That's going to give me negative the square root of 5 plus 3. And there's my answer. Or I could have written it 3 minus the square root of 5. There's 3 different ways you can actually have the answer looking if you wanted to. Does that make sense? Question? Yeah.
So, on like the homework and the quizzes, would you want us to simplify it down that much, or would all 3 of those end up being the answer?
All 3 of those guys would have been the answer, but if I'm looking at doing something like a multiple choice test, you got to be familiar with cleaning it up so you can actually pick out the answer in the lineup. So, I mean, you know, your computer's going to accept any one of these answers. However, personally, I think it looks better to write it as 3 minus the square root of 5, so I probably would have typed that answer in terms of the solution blank, in terms of filling it in or something or other. What about number 26? This one is very similar to the problems we've just done, except for one thing. I don't have numbers in this mess. What do I got? Variables. I got 5 divided by the square root of x minus 1. Again, listen to the directions. The directions state, simplify the rational expression. That's the fancy terms they use. The fact is, we got a radical in the denominator. I can't have a radical in the denominator. So what am I going to do? Look at that denominator. I've got a square root of x minus 1. Whether you have variables or numbers, you're still going to use the same trick. And that trick is multiply by the conjugate. What is the conjugate of the square root of x minus 1? Square root of x plus 1. And what I do to the denominator, I do to the numerator. And these are non-conjugate pairs, so when you multiply, you just kind of put them together. 5 times the square root of x plus 1 divided by, now how do I clean up multiplying conjugate pairs? I'm going to pull it out. What is the square root of x times the square root of x? X. What is the square root of x times 1? Square root of x. What is negative 1 times the square root of x? Negative square root of x. And what is negative 1 times a positive 1? Negative 1. And what a surprise, the outer inner stuff cancel. And you are left with the answer, and usually in factored form is better. 5 times the square root of x plus 1 divided by x minus 1. It's the exact same answer, but notice one big deal. There's no radical in the denominator. That's what they wanted. They're rewriting the way we're supposed to write our solutions. Does that make sense? Whoops, hit the wrong button there. Hold on. It happens all the time. So what we do here is do this, and we're back to running again. Sorry. All right, too many buttons up here. Did that make sense? Now, I have a particular question up here that's on one of your certified sections here, and it's this one. The 5th root of 3x to the 6th divided by the 5th root of 5z to the 4th. Directions say simplify and rationalize the denominator. All right, so the first thing you should do is clean it up. Before you start rationalizing the denominator, you want to clean this guy up. Now there are 2 radicals here. They're both 5th roots of 5 here. That's fine. But here's the deal. What exactly is this numerator here? It's the 5th root of 3 times x to the 6th. That's 3 times x to the 6th. Now what exactly is x to the 6th? That's x times x times x times x, 6 times, right? So I'm going to write it like that for your benefit. This is the 5th root of 3 times x times x times x times x times x times x. 6 of them, right? Over 5th root of 5z to the 4th. Now, I didn't touch the denominator, and I'll explain why in a second, but I want to focus on this numerator. What kind of radical do you have? It's not a square root. It's not a cube root. What kind of radical we got here? 5th root. What it means algebraically means I got to have 5 things grouped together to be able to yank one thing out. Does that make sense? How many x's did I have? 6. So I can group together these 5 x's, because it's a 5th root, and pull 1 x out. Now I'm left with x times the 5th root of, what's left underneath my radical? 3x. Divided by, now I personally would have done the exact same thing to the denominator, except the problem in the denominator is, how many z's do I have? 4. I don't have enough. So I can't pull anything out. Does that make sense? And I got 5, and I've only got 1 5, so I don't have enough of that either. Does that make sense? All right. So I simplified this guy to get x times the 5th root of 3x divided by the 5th root of 5z to the 4th. So I've cleaned it up, but I have not rationalized the denominator. It's a game. So let me just write it down here so I can show you my work. X times the 5th root of 3x divided by the 5th root of 5z to the 4th. Now, let's focus on the denominator. What kind of radical do I have in this denominator? 5th root. So to be able to clean up a 5th root, I got to have 5. Right? So I'm going to, listen it up, I'm going to give the denominator exactly what it needs to be perfect, to have exactly 5, because it's a 5th root. So here we go. I'm going to multiply the denominator by the 5th root of, let's see, how many 5s do I have? 1. How many do I need? How many more do I need? 4. 5 times 5 times 5 times 5. I'm giving myself 4 5s so I can combine it with this 1 5 to make 5 5s. Look at the z's. How many z's do I have? 4. Listen up. How many more do I need for it to be perfect for this 5th root thing? I'm going to give it 1 z. And here's the deal. I'm playing with a fraction. Whatever I do to the denominator, I got to do to the numerator. Does that make sense? It's a game. So I'm going to multiply the numerator by the 5th root of 5 times 5 times 5 times 5 times z. Now, here we go. Look at my denominator, because that's what I'm focusing on. I'm going to combine these two radicals because they're the same thing. They're both 5th roots. So now, because it's multiplied, I can have one big radical. And how many 5s do I have? 5. And because it's a 5th root, for every 5, I get to pull 1 out. There's a 5. How many z's do I have? I got 4 of them here. I got 1 of them here. So when I put them together under my radical, I got 5 z's under my radical. And so I get to pull 1 z out. Does that make sense? Did I lose you guys anywhere? Does that make sense? Now, clean up the numerator. This would be x times the 5th root of, now put everybody in your numerator. This will be 3x times 5 times 5 times 5 times 5 times z. And then I just clean that up. That'll be x times the 5th root of, what's 3 times 5 times 5 times 5 times 5? Let's see here. 5 times 5 is 25. 5 times 5 is 25. So that's 625. Oop, time for a calculator now. So I got 625 times 3. A whopping 1875 times an x times a z. Does that make sense? That's just multiplying the numbers with the xz in my numerator. All over what? 5z. And that's my answer. But the trick is giving the denominator exactly what it needs. Question? Yeah. Oh, because remember, it's a fraction. And it's not an equation. It's not what I do to one side, I do to the other, because there is no other side of this thing. I am just given this particular problem here. Okay? but I am manipulating a fraction. So if I'm doing something to the denominator, I also have to do the same thing to the numerator. So basically, all I'm really doing is multiplying by 1, which doesn't change my problem. So remember, whatever you do to the denominator, you have to do to the numerator. Other questions? Yes, ma'am.
Is there a less lengthy way of doing that?
Is there another way of doing this problem? I mean, I can come up with other bizarre ways of doing it, but it won't be as direct and straightforward. So, you have a way you would do this problem?
No.
Okay, so the answer is no. There's only one way, byway or the highway. No, no, seriously, what I'm trying to do here, there's lots of ways I can explain stuff, but I try to explain stuff in the most direct way possible. This is a game because what's the difference between this problem we're doing, which is one of your certified problems, versus one of the problems we did a few seconds ago? A few seconds ago, they were nice radicals, they were square roots, because all I needed was pairs. But this one is not so nice a radical. It's a fifth root. So whether I do a cube root or a fifth root or whatever, I'm going to do this technique. So to rationalize the denominator, it's going to be falling short somehow. I'm only going to have like 3 out of the 5 that I need. It needs 2 more. So I'll give it exactly what it needs so I can put them all together and then pull everything out of the radical. That's what rationalizing is doing for you. That's the game. Other questions? Yes, ma'am.
Okay, so I thought we were supposed to do the certified for this already, so when I attempted to do it, one of them were asking for the absolute value.
All right, well, you have the question, I will do it. Oh, wait a minute, which certified is this one? We'll go find him. Hold on, I'm game. All right, let's see here, if I can go. Understand, this is what Fridays are for, but okay, it's Wednesday. All right, which one is it? 1.4A? All right, well, Merry Christmas, I'll click on it. Want me to certify? All right, I'll start it. Let's see here. It's thinking about it. All right. Here's the answer on this one. Simplifying the following rational expressions, assuming all the variables are positive. You see that top thing? That's what we're under the assumption. All variables are positive. Because, you know, what is the square root of officially 25? 5, but officially it's plus or minus 5, if you think about it. I mean, if I'm thinking x squared equals 25 and I introduce the square root, I don't know if I want the positive or negative. So with everything being, quote, all variables are positive, and what's the absolute value of a positive number? It's positive, so I don't need absolute value on this one. So did you guys get this one yet? What's the answer? Okay, don't hurt yourselves. A-Y, right? I will submit that answer. Okay, got 1 down out of 12. That's just awesome. All right, so that's correct, John. See, it likes me. All right, so let's go on to the, okay, next one. There we go. Next one. What is the cube root of -8? Now, what's the answer? Cube root of -8. What times what times what is -8? Now, this is a cube root, so you can have negatives on an odd radical. What times what times what is -8? -2. They didn't ask me what the answer is. It's a 50-50 shot. Is it real or not real? Is -2, is that a real number that you know about? Yeah, sure is. -2 is real. All right, so, and then they want the answer. What was it? -2. All right, submit that answer. That's right, I got it correct. Fantastic, there you go. So, okay, we'll go on the next one. And there's the next one. Uh-oh. Got to rationalize this one. All right, so, all right. Andrew, you catching what I'm doing up here? Yeah, welcome Friday. All right, so let me click on this thing here, and I'm going to write down the question. So let me remember what the question is first. There it is. Okay, got it. Uh-oh, I messed up. I shouldn't have clicked on that thing. I got to put them back together again. All right, let me full screen it. It'll fix it. All right, there we go. It is, what was it? Square root of x. I forgot already. Okay. Plus on top, minus on bottom. That's all I wanted to know. Plus on top, minus on bottom. The square root of x plus the square root of z over the square root of x minus the square root of z. Right? how would you, based upon what we just covered here, how would you rationalize this denominator? You'll notice that you have two terms, two individual terms being added or subtracted, in this case subtracted, for the denominator. What would you do? Multiply by the conjugate. When you got a radical plus or minus something or other, you got to use the conjugate. What is the conjugate? Again, rationalize the denominator. What is the conjugate of the denominator? Square root of x plus the square root of z. And what I do to the bottom, I do to the top. Same thing. So it's a ratio of 1. You with me? Now, I'm going to multiply this stuff out. How do I multiply the denominator? What's the square root of x times the square root of x? X. What's the square root of x times the square root of z? Positive, positive, that'd be plus the square root of xz. Just slap them together. What is negative the square root of z times the square root of x? Minus the square root of xz. And last, watch this one. What's a negative times a positive? Negative. What is the square root of z times the square root of z? Z. And notice, what a surprise, and when you full conjugate pairs out, the outer inner cancels. Now, what am I left with in the numerator? Well, you could full this out if you want to. Square root of x times square root of x is x. Square root of x times square root of z is plus the square root of xz. Square root of z times the square root of x is a plus another square root of xz. And the square root of z times the square root of z is plus z. What's the square root of xz plus the square root of xz? How many square roots of xz's do I have? 2. So my answer is going to be x plus 2 square roots of xz plus z divided by x minus z. Does that make sense? All right. Let me go back over here. Let's go certify. Now, how am I going to type this thing in? I got the old keypad right here. This thing's a big old nasty fraction, so I click on the fraction button. Puts me a numerator and denominator. I've got x plus 2 square roots. So I'm going to click on the square root thing there. It's a square root, so put it in there. It's understood. If I needed a different odd root or something else, I put my number up there. It is x times z. Uh-oh, what did I do there? Xz, okay, I didn't have to put the times there. Z, thank you, plus, pick on the outside, plus z, and what was in that denominator? X minus z. You ready? Click on it, cross our fingers. That's right. Does that make sense? All right. We'll go to the next one. 4. All right.
I have an example if you just want to not do certain, I have an example of what you're talking about.
Well, do you want me to? Okay, I can do just the ones you want me to do. You got it out. I'll do it. You're going to make everybody else mad. So, okay, I know. That's what I was afraid of. Square root of y divided by the square root of y minus the square root of 6. Here's my point. If I can certify in front of you guys in 10 minutes or less, hopefully it's like 3 minutes or less, you guys should be able to certify in an hour. All right, so how am I going to clean this guy up? Multiply by the conjugate. What is the conjugate of the denominator? Square root of y plus the square root of 6. Square root of y plus the square root of 6. On your mark, get set, go. This one, I'm just going to put them together. Square root of y times the square root of y plus the square root of 6. The denominator, I'm going to full out. Always full out conjugate pairs. What's the square root of y and the square root of y? Y. What's the square root of y times plus 6 plus the square root of 6y? What is negative 6 times the negative square root of 6 times the square root of y? Negative square root of 6y. And here's the last one, and be careful with your signs. What's negative square root of 6 times positive square root of 6? What's a positive times a negative? Negative square root of 6 times square root of 6 is 6. And what a surprise, the outer inner stuff cancel, as always with full stuff on conjugate pairs. What are you left with? The square root of y times the square root of y plus the square root of 6 divided by y minus 6. No more radicals there. I could type it in like this, but I'm going to go ahead and distribute and make it look good. What's the square root of y times the square root of y? Y plus, what's the square root of y times the square root of 6? Square root of 6y over y minus 6.
Why 6?
Y6, same thing. You'll take it.
Yeah, it would be good.
Yeah. All right, so boom, boom, boom. Okay, what is this? It's a fraction. So P, punch it in fraction. What do I have? I've got y plus the square root of, and it's a square root, so I can put a 2 there, just leave it alone. 6y divided by y minus 6. How did I do? Nothing but UNC Charlotte Green. There it is. All right, keep going. Actually, I got to do out of 12, but I think if I do 80% of them, it gives me 100% on it. All right, so what about this one here? Can I do this one in my head? Yes. All right, so how would you do this one in your head? Fourth root. So a fourth root, you can clean these guys up because I'm looking for groups of 4. So I'm grouping together by 4, but there's a fast way of doing this. How many x's do I have? 28. So this is like a 1/4 power if you think about it. Rational radicals are fractional powers. And when I take 28 and put it into groups of 4, 28 divided by 4 is how many? How many groups of 28? How many groups of 4 do I have? 7. So this answer, I'm just going to be a fraction here. It'll be a fraction, and in the top it'll be x to the power. If I want to do a power, I'll do that. It puts the power up there. So I'm trying to show you guys some other buttons on the computer here. X to the 7th. Click off of it right there. Times. What about y to the 24th? I'm taking the 4th root of that. So I've got 24 y's. I want to put them in groups of 4. How many can I pull out? 6. So it'll be y to the, get the old power thing going there, bingo, to the 6. Now let's work the numbers. What is the 4th root? Because it's a fraction, I'm going to take the radical of the top over the radical of the bottom. What is the 4th root of 16? What times what times what times what is 16? 2. Whoa. Oh, because it's even. Well, let's, I will try a similar question. I will never accept a strike, so get that. Fine. Okay. So it's 81 now. Okay, fine. All right, we'll still do the same thing. But here's the thing. Because I wasn't paying attention to this, and we need to pay attention. Did they say anything about the variables being positive? All right, this is the kind of question you guys were talking about. The variables being positive. They didn't say that. I've got to make, because this is an even root, the answer, anytime you've got an even root, the answer should always be positive. What makes things positive? Absolute value. So I stick the absolute value. Now inside I'm going to stick the fraction here. All right, what's the x to the 24th? If I'm taking the 4th root of that and pretending to put in 4 groups of it, how many are in each group? X to the, what? 6. 6 of them. All right, what about the z to the 28th here? 7. We've got 28 for the 4th root of z to the 28 makes z to the power, what is it? 7. Good. And what's the 4th root of 81? What times what times what times what is 81? That's 3. And I mean, I could put the absolute, I can put 3 outside the absolute value because it's already positive, but the computer should not care. It's thinking about it. It likes it. Okay, so there you go. Does that make sense? No. You use the absolute value when it's an even radical. Okay, yes. When it's an even radical, because, and in the problem, it stated the variables were not positive. Remember that first question? It said the variables were positive. I didn't have to put the absolute value on it. But there they didn't say anything about the variables. So I had to put absolute value because it's a 4th root. Anytime you got an even root, the answer is always positive. Yes, ma'am?
When I did the problem before, they said only put the absolute value things right only on the x, not on the whole thing.
Well, okay. So I clicked on absolute value, and then I clicked inside of it to put my fraction. If you click on the fraction and then do absolute value, it'll stick it in the numerator. So it's the order of which you're clicking it. But here's the deal. It won't matter as long as the variables are inside the absolute value. Because what is the absolute value of 3? 3. So the 3 doesn't matter if it's inside the absolute value or outside the absolute value. What's the definition of absolute value? Well, by definition, it is the distance away from 0, but it's distance. Distance is always positive. So the absolute value of 3 is 3. The absolute value of negative 3 is positive 3 because you're 3 units away from 0. Does that make sense? So since you already got a positive 3, putting that inside the absolute value really didn't matter. So there's different ways you could type in the answer and still get it right. Okay. Next. This one is what kind of radical? Odd. It's the 5th root. So do I need to put any absolute values on this mess? No. So what is the 5th root of 243? Well, let's see here. 243 is 3. All right, so let me show you something, brother. Again, beauty of using the calculator here. I would like to know, just on this part, what is the 5th root of 243? And I want to use my calculator to figure this thing out, to see if it works nicely or do I need to do factoring and just pull out what's in common. If I want to type this in on my calculator, how do I do it? There's 2 ways to do it. There's an easy way and a hard way. The easy way is this. You know, it's tough finding these radicals, especially the 5th root radicals on the calculator. You can find them, but it's a pain. But there's an easier way. Remember what we said before. Properties. The nth root of x, what is an nth root in terms of fractional radical exponents? It's the same thing as x to the what? 1 over n power. So what is the 5th root of 243? The same thing as? 243 raised to the 1/5 power. So I can type that in on my calculator, which I did. 243, and I hit my power button, which is the caret sign on the calculator, raised to the, and then I type in 1/5. Does that make sense? And what does it tell me? It's 3. So let's go back to my problem now. See if I can do it without a calculator. All right, here we go. I'm trying to take the 5th root of 243, x to the 6th, y to the 17th. All right, the 243, because you can break up it through strict multiplication division, I can break up radicals. What was that 5th root of 243? It was 3. Now, let's talk about the variables. I'm trying to do a 5th root. I've got x to the 6th. How many x's do I have inside this radical? 6. But for every 5, I get to pull 1 out. So how many x's do I get to pull out? 1 x. But how many x's are left inside? 1. I'll put that one back in just a second. Now look at the y to the 17th. I'm trying to group together 5. For every 5, I get to pull 1 out. How many times does 5 go into 17? 3 times, with how many left over? So I can group together 3 groups of 5. Does that make sense? So that would be y raised to the what? And I hit the keypad and hit the power thing here, raised to the 3rd. And then I get to multiply it times the 5th root. I'm going to hit my radical, but you notice when I hit my radical, this is a special. It's not a square root. What radical is this? 5th root. You see where the cursor is? I'm going to type in a 5 here. And now, what were the variables left over inside the radical? With the x's, I had just 1x, but with the y's, I had what? Well, 2 of them, so I have to put the power 2. Does that make sense? And then I submit my answer, and it's all nothing but UNC Charlotte Green. Does that make sense? Questions? 6, okay. Next. What about this one? What kind of radical is this? Square root. That is called an even radical. With an even radical, what do you got to do? All right. So do absolute value when it's an even radical. Is this helping? Yes. All right. Absolute value of, let's see what we got here. All right. Clean this up. I've got 3. That's pretty much prime. I don't have enough. I don't have pairs of them, so I can't touch the 3. What about x to the 6th? I can pull something out of that, dude. What can I pull out? X to the 6th. This is understood to be an x squared, so I got x to the 6th. How many pairs of 2's do I have there? 3, so that'd be x cubed, power 3. Does that make sense? Make sure I'm not losing anybody when I'm doing this kind of fast in my head. Inside the radical, so click there. All right, what about the, let's see, the y's? I only have 1 y. So here's the deal. I have a square root. What's left underneath the radical? It's a square root, so I don't have to put anything there. I've got all the x's went away, but the 3 was still there. And the y was still there. Does that make sense? But because this was a square root and in the directions, they did not put the variables were positive, I got to throw the absolute value mess on this stuff because it's an even radical. Submit the answer. Let's see if it liked it. It doesn't like it.
Yeah, it doesn't use the everything.
Okay, so this is now we're getting into the part that this is now a computer thing. I put the square root inside the radical. It didn't like that. The square root is understood to be positive, so you don't have to have the radical inside the absolute value. So I never accept a strike, so I'll still try a similar question.
If you accept a strike, you just get it wrong completely.
Yeah, but remember, when you certify, you get it wrong, but as long as you get 80% of the total number of questions, 12, you still get certified. You can miss 2 or 3 or something like
But
that.
if you try different questions to count the previous one as wrong,
No, he's going to count you right and give you 80%. And once you get 80%, you've certified, and it automatically puts 100 in my grade book. All right, so let's try this one. Same idea, 14 here. So it's still a square root, so I still want absolute value. So let's try this, absolute value. X to the 14th. I'm taking the square root of that. What's that going to give me? X to the 7th. Okay. And because 7 is odd, it's going to like this. And then what's left is going to be inside my square root. The square root of 14 is 2 times 7, but there's no something I can't pull out of that. So I'm still left with a 14, and I got a z. So I think the computer's going to like this. It's thinking about it. It's looking hard at it. It's maybe I should submit again. Yeah, okay. 2 times is a charm. There you go. So it doesn't want the radical inside the square roots. Officially, there's nothing wrong with that. You understand? It's still the same answer, but now you're playing computer stuff. Yeah.
Why is the square root of 14z outside of the absolute value?
Well, honestly, it can be inside or outside, but because the square root, what kind of square root is this guy? What's the sign in front of it? Understood, because they didn't write it. It's understood to be a positive. This is a positive square root. The absolute value of a positive is the same thing. So the computer says there's no reason to put the square root inside your absolute value. I'm saying it's the same answer. Why didn't you accept it? I'll argue with these people later about that. But the fact is the computer, you're trying to get certified, so please the computer, it's saying when you're pulling out the variables have to be positive. You need the absolute value when to pull out the variables. But the square root's understood to be positive, so you can actually leave it outside the radical because it's still positive, so it's still the same answer. And this is the way the computer wants it. In the real world, it won't matter because it's the same answer. We'll accept it. So on my test, I'll give you 100 for either one of those answers. Okay. All right. What's the next one? Next. All right. This one's not too bad. Where is that negative located at? Outside or inside the radical? Outside. What's the square root of 100? 10. With the negative outside, what's my answer? Is that a real answer or not a real answer? A not a real answer is a negative inside the square root. Square root of negative 10 is not real. But negative the square root of 100, which is negative 10, is a real answer. And then what is that answer? Negative 10. Hey. Okay. And then, all right, here we go. What about this one? The square root of 9 over 49. What's the square? Because it's the square root of a fraction. You take square root of the top over square root of the bottom. What's square root of 9? Square root of 49. Is that a real answer or not? It's a real answer. And what is the answer? And I'm going to put it in a fraction because this is a computer that likes it. What is it? 3 over 7. Thank you. Okay. And notice, did I do all 12 of them? No, I did 9 out of 12, which is 80%. And once I got 80%, I've got full credit for this thing. And it tells me, what's that? Yes.
is quiz 3, it's on 1.4 or 1.5?
Quiz 3?
Yeah.
1 point, let's see. Quiz 1 was 1.3. Quiz 2 is 1.4. Quiz 3 is 1.5. Does that help?
Yeah.
One section at a time.
I was wondering, because it's due tonight,
Well, wait a minute, hold on. Okay, full screen. Here we go.
Sorry.
We just finished up this. Does that make sense? Okay, so this is the end of section 1.4. So what's next? Wait a minute, I still got what? 30 minutes left in class? All right, well, wait a minute. Let's cruise on this one. Let's see what you guys know. Now I'm in section 1.5, and look, I have the ability to change dates. So if I run a little bit behind, don't freak out. It's okay. We're working together. Because you guys understand this whole deal. I'm trying to work with you guys to work this system out. And I'm learning it just along with you guys. One, at the end of the semester, I'm going to ask you guys lots of questions whether you like the system or not. And two, did you learn a lot through this technique of systems and stuff? And I am more than happy to push back something or other to make sure you guys have a chance to get it done. But see, the quiz is supposed to be a pre-section quiz, which means you're supposed to do it before class, before coming to class, but you still have till midnight. So hopefully by the time I do this, and watch my awesome video, you'll be able to, to do this stuff. But it's a pre-section quiz, so, but, if you want to come to class and then get it done, that's fine too, but you got to get it done that night. Yes, ma'am?
So we're not gonna be penalized if we don't do the quiz before class?
No, but you have to do the quiz by the end of that class. So it'll be like due tonight at 11:30 or something like that. Okay? But all my guns are at home, so I didn't bring a gun here, so I'm not going to shoot you for not getting the quiz done before class, but that's the goal, is to get it done before class so you could have a better feel for this material. But as long as you get it done by the end of the day of the class that we covered, I still got it prepped for you. Does that make sense? Okay. All right. So, section 1.5 is on polynomials and factoring. Again, most of this stuff should be reviewed in terms of factoring and things like that, and polynomials. First off, definition. An expression in the form of ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus ... where a, b, and c are real numbers, and the exponents n minus 1 are going to be positive integers, 1, 2, 3, 4, 5, 6, numbers like that, whole numbers. This is called a polynomial. An example would be like 4x cubed plus 3/4 x. Coefficients can be anything, but you notice it's times x to the first minus 1. That's a polynomial. The coefficients are the numbers in front of each term. A, B, C, ... are called coefficients. So in this example, 4, 3/4, and the sign goes with it, -1 are the coefficients. The degree term is the term, largest exponent you have in your problem. So the definition, degree term, well, the degree term is the term with the largest exponent. So in this problem, 4x cubed plus 3/4 x minus 1, the degree term would be 4x cubed because the highest exponent is 3. So the whole term is the degree term. The degree is that largest exponent. So what's the degree of 4x cubed plus 3/4 x minus 1? The degree is 3. That is the largest exponent. The constant term is the term without the variable, and the term without a variable would be the -1 in this example. A monomial is a one-term polynomial, 5x cubed, and that's it, one term. That's a monomial. Binomial is a two-term polynomial, two terms, 3x plus 4, or 17x squared minus 45, or 5x cubed plus 17x. Those are binomials because they got two terms. A trinomial, same deal, that's a three-term polynomial. Ax squared plus bx plus c, that's a quadratic. That's also known as a trinomial because you got three terms. Yes, ma'am?
What's the degree of the term?
The degree of the degree term is the term, which are said, terms are separated by pluses and minuses, that has the largest exponent. So you see this example here, 3x squared plus 8x minus 6. What's the degree of this polynomial? No, the degree is just a number, 2. The degree term is the term that has that 2 in it. So what's the degree term? 3x squared. So 3x squared is the degree term. The degree is the 2. It's a definitional thing. Does that make sense? All right. So on our marks, get set, let's go. X to the 5th plus 2x cubed plus 7x plus 9. What is the degree term? 5. What is the leading coefficient? Coefficient is the number in front. The leading coefficient, now with polynomials, you like to write this stuff in decreasing order. Decreasing in terms of powers. 5, 3, 1, and that's understood to be the constant or the zero term. So what is the leading coefficient? What is the number in front of this thing? Understood to be 1, even though we don't write a 1. What about 4x squared plus x? What is the degree? 2. Highest exponent. The degree term is 4x squared. What is the leading coefficient? 4. It's the number 4. That's in front of the x squared. X. That is a monomial. What is the degree of x? What's the power on this thing, even though we don't write it? 1. What is the leading coefficient? What's the number in front of this thing, even though we don't write it? 1. 2. 2 is a constant. So it's a constant term. What is the degree? 0. It's a constant term. There is no x's. Does that make sense? So that's x to the 0, which is 1. So the degree on a constant is always 0. It's a trick question. And what is the leading coefficient? What is the only coefficient? 2. And then be careful. Remember what I said about polynomials. Polynomials need to be written in what order to ask about leading coefficients and all this stuff. Descending or decreasing order. They're trying to mess you up on this one. I've got x squared plus 2x cubed plus 7x plus 9. The first thing you do to polynomials before you answer a bunch of questions about it is write it in decreasing order. So what is the degree term, the largest exponent thing here? What term is that? 2x cubed. What's the next power term down? X squared. It's understood to be positive, so it'll be plus x squared. What's my next term down? Plus 7x plus the constant term 9. Now this thing is written in decreasing order. Does that make sense? Now answer the questions. What's the degree? 3. And it's easy to find when you write them in decreasing order because it's always out front with the largest exponent. What is the leading coefficient? 2. And just a trick question, what's the constant coefficient? 9. The constant coefficient would have been 9. Does that make sense? All right, perfect. All right. What we're trying to do in this particular section is do the algebra. What kind of algebra can you do with polynomials? You can add, you can subtract, you can multiply, and you can play around with division. But the nice thing about polynomials is this. If you add polynomials, you get polynomials. Subtract polynomials, you get a polynomial. You multiply polynomials, you get a polynomial. But once you divide polynomials, you get a different kind of function called a rational function. So how do I add polynomials? Well, when I got one polynomial, x to the 4th plus 2x cubed plus 7x plus 9, added to x cubed plus 2x squared plus 1, basically because it's a plus, I can drop the parentheses. This is x to the 4th plus 2x cubed plus 7x plus 9 plus x cubed plus 2x squared plus 1. And the trick on adding or subtracting polynomials is group together like terms. And I like to write them in decreasing order. How many x to the 4th do you see? Just one term there, x to the 4th. How many x cubes do you have? I got 2x cubed plus another x cubed. How many do I have now? Plus 3x cubed. X squareds. How many x squareds do I have? I just got 2x squared, one term of it, plus 2x squared. How many x's do I have? Just one there, plus 7x. How many constants do I have? Like terms. I got a 9 and a 1. How many is that? Plus 10. And that is my resultant polynomial. Degree would be 4. The leading coefficient is 1. The new constant term would be 10. Does that make sense? What about subtraction? The only thing you've got to remember about subtraction is when you subtract a polynomial, that negative is going to distribute, so change the signs. So I'm going to rewrite this as x to the 5th plus 7x to the 4th minus 2x squared plus 9. That negative is going to distribute there, and that's going to give me a negative makes it plus 2x to the 5th. That negative times a positive is a minus 2x to the 4th. A negative times a negative is a positive plus x cubed. A negative times a positive is back to a negative minus 1. I distributed my negative. Now combine like terms. Again, in decreasing order, I got an x to the fifth and a 2x to the fifth. How many x to the fifths do I have? 3x to the fifths, and I usually mark through them when I'm done with them. That way I don't screw them up. All right, what about x to the fourth? I'm going in decreasing order. X to the fourth, I've got 7x to the fourth here minus, watch the sign, minus 2x to the fourth. How many do I have? Plus 5x to the fourth. Put a line through them because I'm done. X cubes, I just got one term of them, plus x cubed. X squared, just one term of them, minus 2x squared. X's, I don't have any x's at all. And then what about the constant? I've got 9 minus 1, which is plus 8. And there's my solution. Multiplying polynomials. When you multiply the coefficients, but when you multiply the variables, what happens to the exponents? When you multiply, what do we do with the exponents? Add them. So, what is 2x to the fourth times 7x cubed? Well, first multiply the numbers. What is 2 times 7? 14. Now you got your x. What's x to the fourth times x to the cube? When you multiply, you add exponents. 4 plus 3 is 7. 14x to the 7. Does that make sense? All right. But now look at that was two monomials multiplied together. Now I have a binomial times a monomial. 3x squared minus 9x times 2x squared. What am I going to do? I'm going to distribute. So this is 3x squared times 2x squared. Multiply the numbers. 3 times 2 is 6. X squared times x squared is x to the fourth. And then a negative 9x times a 2x squared. Negative 9 times 2 is minus 18. X times x squared is x to the third power. And there's my resultant polynomial. As mentioned before, what do you do when you have multi-term polynomial times multi-term polynomial? Full it out. And just to remind you of the full method, which we've beaten to death, no doubt, many, many times, I have a plus b times c plus d. Full it out. First, a times c, outer, a times d, inner, b times c, and then last, b times d. First, outer, inner, last, where the full comes from. So, what is x plus 7 times x minus 2? X times x is x squared. X times minus 2 is minus 2x. 7 times x is plus 7x. And last, 7 times negative 2 is negative 14. And now you always want to clean it up by combining like terms. This is x squared. What is minus 2x plus 7x? Plus 5x minus 14. What is 3x minus 9 times 2x plus 1? Well, full it out again. 3x times 2x is 6x squared. Outer, 3x times 1 is just 3x. Inner, negative 9 times 2x is minus 18x. And last, negative 9 times 1 is negative 9. Just remember, the sign goes with it. Now combine like terms. This is 6x squared. 3x minus 18x is minus 15x minus 9. And these, you don't have to have, degree 1 terms times degree 1 terms. You can actually have higher powers here. What is 2x squared minus 9x times 2x minus 2x plus 1? 2x squared times 2x. 2x squared times 2x, 2 times 2 is 4. X squared times x is x cubed, because when you multiply, you add their exponents, understood to be a power of 1. Outer, 2x squared times 1 is plus 2x squared. Inner, negative 9x times 2x. Negative 9 times 2 is negative 18x times x is x squared. And then last, let's see here. Negative 9x times minus 1 is negative 9x. Kind of ran out of room there. But I'm going to group together like terms. So this is 4x cubed. 2x squared minus 18x squared is what? What's your sign? Negative 16x squared minus 9x. Does that make sense? And again, the common mistake on this stuff is people screwing up the signs. All right, and just for practice, when they give you weird variables like what is x plus y times z minus w? Well, it doesn't matter. You're still going to fold it together, so they're not like terms. You just slap them together. What is x times z? xz. What is x times minus w? Watch the sign. Minus xw. What is y times z? Plus yz. What is positive y times a minus w? Minus yw. And that's pretty much pulled out. Does that make sense? All right. What about these guys getting longer? Now, we call it the full method when we have two terms being multiplied to two terms, first, outer, inner, last. This is what I call the extended full method. You're just basically distributing it using a full method pattern, but you just have more terms. So let me show you how to do this. X plus 3 times x squared plus x minus 2. You take the x and you distribute. X times x squared is x cubed. X times x is plus x squared. X times minus 2 is minus 2x. And then work the next term. 3 times x squared is plus 3x squared. 3 times x is plus 3x. And then 3 times minus 2 is minus 6. So it's a extended full thing, but I'm really distributing each term from the first guy through the second polynomial. Now collect like terms. I got x cubed. I got x squared plus 3x squared. That's plus 4x squared. I got minus 2x plus 3x. That's plus x minus 6. And there's my result. And it doesn't matter if you distribute through the front or distribute through the back. Here, look at this one. I got 3x cubed plus x squared minus 9 times 2x plus 1. It doesn't matter if I take the first one and distribute to the second one, or the second one and distribute to the first one. You're going to get the same answers. Let me show you. 2x times 3x squared is going to be 6x to the fourth. 2x times x squared is plus 2x cubed. 2x times negative 9 is a negative 18x. Now 1 times 3x cubed is plus 3x cubed. 1 times x squared is x squared. And 1 times minus 9 is minus 9. Combining like terms, I got 6x to the fourth. 2x cubed plus 3x cubed is 5x cubed. And put a line through them so you don't use them again by accident. X squared, there's only one term, plus x squared. There's only one term with x in it, that's minus 18x. And last constant term, minus 9. And there is my result. Now, we've talked about this before when we were doing conjugates, which means you just change the sign. But you have a nice pattern because when you full out conjugate pairs, the outer inner stuff always cancels. You saw that with all that rationalizing stuff we did. But it's going to the same thing with these polynomials. Now, if I do it by hand, I just want to show you something rather. X plus 3 times x minus 3, you can get x times x is x squared. X times minus 3 is minus 3x. 3 times x is a positive 3x. And 3 times minus 3 is a minus 9. And you'll notice that the minus 3x plus 3x cancels. You're left with x squared minus 9. That's me doing the full method. But what they want you to clue into it is catch a pattern. What's the pattern on this stuff? Well, when you're multiplying out conjugate types, basically you just take the first term and square it, and take the last term and square it, and it'll be a minus in the middle. Because remember, conjugate pairs always have one's going to be positive, one's going to be negative. So the last term when you multiply it out has to be a minus. So based upon that, without me folding it out, you're supposed to catch a pattern. So tell me what the answer is. What is 2x plus 3y times 2x minus 3y? Right, it's going to be the first term squared, 2x, quantity squared. Notice my wonderful use of parentheses there. And it's going to be a minus the last term being squared, 3y quantity squared. But to clean that up, remember strict multiplication division, I can distribute powers. So 2x quantity squared is going to be the same thing as 2 squared times x squared, or 4x squared. minus 3y quantity squared, that's 3 squared times y squared, which is 9y squared. There's my solution. Now, you can memorize these formulas and be familiar with them. When you have a plus b quantity squared, that's equal to a squared plus 2ab plus b squared. It's a formula. If you get lost, remember square means multiply by himself, and end up filling it out. But here's the deal. I've seen so many students end up crashing and burning in this class because they want to get through this class in 10 seconds or less, and they don't think about what the problem they're doing. So, how many times have I seen this? X plus 5 squared. You know what that's equal to? Clearly, x squared plus 25. Wrong, you fail, go back to, I don't know, 9th grade and start all over again. You can't distribute powers unless it's what? Strict what? Multiplication division. This is such a common mistake. I see this stuff all the time, and then they won't wonder why their math doesn't work out right. Only through strict multiplication division can you distribute powers. So to truly understand this problem, what does square really mean? X plus 5 quantity squared means x plus 5 times x plus 5. And if I was going to multiply this out, you don't have to memorize the formula on this stuff. I'm not going to quiz you on that. You should just know how to do it. If you were to multiply this out, how would you do it? Full method. X times x is x squared. X times 5 is plus 5x. 5 times x is another 5x. And 5 times 5 is 25. And you end up getting, when you combine the middle terms, that's why it doubles up the middle term. That's what the formula tells you. It's x squared plus 10x plus 25. And notice when you distribute the power, you really miss out on that middle term, which really screws up the problem. Does that make sense? So what is 2x plus 3y quantity squared? Well, that's 2x plus 3y times 2x plus 3y. That's going to give you 4x squared plus 6xy plus another 6xy, it doubles up that middle term, plus 9y squared. Cleaning it up, that gives you 4x squared plus 12xy plus 9y squared. What about when you minus? Well, it's the same thing, a minus b quantity squared, except the middle term is going to be negative. So it's a squared minus doubling up the a times b plus b squared. But again, if you get lost, FOIL it out. X minus 4 squared means x minus 4 times x minus 4. You don't get to distribute the power. X times x is x squared minus 4x minus another 4x plus negative 4 times negative 4 is 16. That gives you x squared minus 8x plus 16. And then this one, 2x minus 3y quantity squared is, same thing as 2x minus 3y times 2x minus 3y. Pulling it out, this is 4x squared times a minus 6xy times another 6xy times a plus 9, 3 times 3 is 9, y squared. That gives you 4x squared minus 12xy plus 9y squared. Does that make sense? Oh, the class is not done yet. You guys don't get to leave unless you really want to fail this class. Now, here we go. And then there's also these other formulas that are very advantageous. There's two different ways you can do this stuff, and that is you can actually, cubic means multiply it 3 times out for the first two guys and for the last one, or you can apply the formula for this thing. Okay? So that's actually up to you, but let me show you one of these guys. I've got x plus 4 quantity cubed. According to this rule, and this is a formula, you can fold it out 3 times, you'll get the right answer, but it takes a lot of time. These formulas are really designed to help you out and do it quickly. The formula for a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. A is your first term plus b is the second term. So this answer is going to be, write the formula. So x is a cubed plus 3 times a is x, squared b is 4, plus 3 times a is x, b is 4, but we're squaring the 4, plus b, which is 4 cubed. You see what I'm doing there? I'm applying the formula where a is x and b is 4, and I plugged in the formula. Now all I got to do is clean it up. This is x cubed. 3 times 4 is 12. That'll be plus 12x squared. 4 squared is what? 16, and 16 times 3 is 48. So this becomes plus 48x plus 4 cubed. 4 cubed is 64. And there's my answer. And I'm applying the formula for this guy. And the difference between a plus b cubed and a minus b cubed is this. When a plus b cubed, all the terms are positive. When it's a minus b cubed, the first term is positive, and the second term is negative. The third term is positive, the fourth term is negative. So it alternates signs. So x minus 6 quantity cubed, here a is going to be equal to x, b is going to be equal to 6. And I'm going to plug it into my formula with these signs. A cubed, that'll be x cubed, minus 3 times a, which is x, squared times b, which is 6, plus 3 times a, which is x, times b, which is 6 squared, minus 6 cubed. Cleaning it up, this is x cubed minus 6 times 3 is 18x squared. 6 squared is 36. 36 times 3 is 108, plus 108x minus 6 cubed is a whopping 216, minus 216. And there's this formula. So these formulas can be quite handy, aka memorize them, with these sums cubed and difference cubed and stuff. And next time we'll work on some of our factoring methods and stuff like that. One last thing though, don't forget, go back to our Moodle site. Do not forget, on Friday, we have our first review session. That stuff that I did on the pre-section quizzes and the 1.4 that I did, Andrew is going to be working these kind of problems in class with you guys. So come, it's in here on Friday from 12:30 to 1:45. So be here. See you guys on Friday, if you can come.